Started if you want to hit record.
Okay, you're good to go.
All right, well, good morning, guys. Welcome to Monty's Crop School. Had one of these a couple years ago and it went pretty well, so we thought we'd do another one. I hope we're able to provide you with some valuable information to help you in your business. My name is Paul Miles. I'm the Eastern Region Director for Monty's. We're joined by Joe Dedman, who's our agronomist. Joe also handles the Mid-East region position. And Phil McCutchen is Vice President of our sales team. And then Dennis Stevens will be joining us, and he's the president of the company. Kind of go over the agenda here just a little bit. Phil's going to talk some about soil health, carbons, and sugars. And then I'm going to talk on, is your fertilizer working for you, ortho versus poly, where to use certain fertilizers, and can we maximize your fertilizer uptake? Then Joe's going to talk about an interesting topic of salt. Salts are a big issue, hindering root development. So we're going to let him discuss that. And then Dennis is going to talk to us about water conditioning and talk about your water. And then we're going to wrap it up talking a little bit over our corn and soybean programs and go from there. If anybody's got any questions, please, tune in, click your mic up, ask the question. We're going to try to keep this moving along pretty smooth. So hopefully we can stay on schedule. And if, like I say, any questions, please ask them. All right, we're going to start with Mr. Phil. If he'll do the portion on soil health, please.
All right. Well, good morning, everyone. Let me get my screen shared here. All right. Should be in business. So this morning, what I want to spend a little time talking about is soil health. And really, that's the basis of what Monty's really focuses on. And then how we can use Humic technology to improve that. And so just a little bit about myself. I been with Monty's about 3 years now. I spent some time in the seed business before that. I live in southwestern Indiana. We farm here corn and soybeans, about 3,500 acres, and spent some time at the farm, and then also enjoy camping, and then I fly as well. So just I always like to share a little bit about who's talking with you, and a little bit about my background. So this morning, again, talking about how critical our soil health is, and really how Humic technology can improve that. And today we all kind of know that our soil is a really important part of our business, right? It's the foundation in agriculture that we all thrive on. But we also know that sometimes our soil maybe isn't the healthiest. We do things sometimes that aren't the healthiest to it. When we see things, we know that weather can impact our soil, insects, erosion, high salts, which we'll talk about today, over time can imbalance the soil. And once we get that soil imbalanced, then we start to have problems with it robbing yield potential that's out there. So what does an imbalanced soil look like? Here's some characteristics that we often see and think about. You don't have that good smell. If you ever driven tractor and you kick that door open and you just, that smell whenever you're working the ground or when you're out there, something just doesn't smell right. Erosion can be a problem. A lot of times we get soil that gets cloddy or gets really hard to work, and that soil structure gets out of balance. Earthworm activity is always a good gauge of soil health. waterlogged, poor drainage. We have spots where water's just not coming off. We got compaction. Insect disease problems actually could be a result of poor soil health. Organic matter, is it decomposing like we want it to? That's a good sign of soil biology. And if it's not breaking down, that means we've got our soil out of balance. High salts again. It takes more fertilizer, more chemicals to do the things that you're trying to do in your soil. And then high weed pressure. So that's what an out of balance soil looks like. So you can imagine that a balanced soil would be pretty much the opposite, where we have a lot of active biology in the soil moving. Erosion is better because our soil structure's in better shape. You got earthworms and other biological material in your soil. Water uptake's really good, so on and so forth. Less salt in your soil, and just an overall more balanced soil. Now, that's easier said than done because there's really three parts to a balanced soil. There's a biological component where we think about the living organisms that are in the earth. We know that those are really important. We'll talk about those. We got a geological structure that we need to think about. Things like compaction and water holding, just what's those soil colloids look like, and how are they performing? And then the chemical, which is the interaction with the nutrients in the soil. We think about things like CECs and how nutrients are bonded and tied up in the soil. So you really got to balance all three of these things to have a truly balanced and healthy soil. So let's just look at the biological portion of soil health. So this was an interesting slide that just kind of shows what's in that soil from a biology standpoint. In a good acre of soil, you might see 900 pounds of earthworms. So if you like to fish, hey, you'd be in luck if we had that many earthworms in there. You look at all the fungi and the bacteria. And the crazy part is that we only know about 1% to 2% of the microbes in our soil. I mean, we're still learning that. And biology is a huge part of what happens. Mother Nature kind of does its job without us even knowing all the things that it does for us. But we know what happens if that soil is not balanced and microbial activity isn't there. We also know a lot of us have taken soil classes or understand that pH is important in the soil as you think about unlocking the nutrients that we're putting in the soil. We know that depending on your crop, getting that optimum pH of 6 to 7.5 is very important. You can see that can change pretty rapidly. And if we're investing in fertilizer, we want to make sure that it's the most optimal for the plant. So that's pH is an important part of a healthy soil. Perhaps one of the biggest things as we think about the chemical side of the soil biology is how the soil reacts and how it can attach itself to nutrients or cations. And you've probably heard the term of a cation exchange capacity, or CEC. And what that really means is just, again, the soil's ability to latch on to nutrients, to latch on to positively charged particles in the soil, to allow it to do what we want. And really, so if you think about a clay particle, clay, like where I'm from, and I think in a lot of your areas, you can get a lot of tight clays that can bind magnesium, bind your nitrogen, your calcium, can really hold it on tight in the soil. CECs generally are very high in a clay soil. We'll talk about some ways that we can help make some of those nutrients available in clay soils here as we talk about our Humic technology. On the other side, we've got our sandy soils, which, you put material and you put nutrients down, and they tend to go right through that soil profile. So they have a really low CEC. So they don't grab a hold of things. And so we have to manage those soils a little bit differently as well. And if anybody has questions, please don't hesitate to raise your hand in the meeting, or just click your mic and ask your question. So the other part of having a balanced soil is really understanding our nutrients and understanding of what levels they actually are. If you think, I'm just going to put a bunch of extra nitrogen on, which I know when you get into Paul's area and where many of you farm, you got to be really careful about that, and we're protecting our waters. Um, but for example, if you put too much nitrogen on, it sounds like a really good thing for a lot of our crops, but it can also create an antagonism with other nutrients. So, for example, nitrogen, too much nitrogen can tie up potassium and also calcium. And as you can kind of look down through this list, you can see that it's really important that we keep all of the nutrients balanced in our soil. It's not only important for the plant to have the right balance of nutrients, but also in our soil so things don't get tied up or antagonize each other. So you can see there's a lot of chemical interactions that are occurring in the soil. We could really dive into a lot of these a lot deeper, but we don't want to. We just kind of want to introduce some of these concepts today. We've got a team that would be happy to sit down with you to share and dive into these a little bit deeper. If you're seeing some of these problems in some of your fields, we can help try and figure out a way to improve that. So how do you know if you're having a problem? I know a lot of us soil test. That's a really good way to make sure that we understand what's going on in our soils. We paired up, this is a waters lab, is one of the labs that we use, but there's several labs that we can help you get in touch with and help analyze and understand what's going on in the soil. Also, it'll share information about salt indexes, um, excuse me, nutrient availability, and those types of things. Also, we have tools like tissue sampling that's really become very helpful in the last several years as we think about knowing what's in the soil is important, but knowing then what the plants can grab a hold of and make available to the plant, which is ultimately what we're trying to do. And so these tissue samples allow us to, throughout the season, be able to understand what nutrients are in the plant. Are they available when the plant needs it? Which is again what our end goal is. So tissue sampling, if it's something you've not done, I think it's really good to help understand it and fine tune that nutrient management that we're trying to accomplish. The other thing it allows us to do throughout the season is if we need to make adjustments, we have more tools now, whether it's side dress, Y dropping, if you have irrigation, being able to impact a crop in season can really be beneficial as well. So we find out we have this imbalanced soil, and what do we do about it? And so Monty's kind of has a unique approach where we like to use nature to help rebalance nature. And so really the key that we use through this process is humics. We have been in the humics business for over 30 years and really working with it even longer. So what are humics? They are really what is formed whenever you start to see the things above ground, all the living things above ground start to break down and decompose. And you think about organic matter, what happens once it dies and gets down into the soil. And humics are a major component of this organic matter. And we'll talk about humics and then eventually coal as well. So in the upper left corner of the screen, you can see this is the living biome that's above the soil. Over time, things die. It goes through a process of heat and pressure. Things decay, and you get peat, which eventually, through this process, turns to lignite, which then eventually turns to coal. We all know the benefits and how we use coal in the country. I'm from coal country. Coal trains go by here all the time, and a lot of our areas provides a lot of our energy source. But the part we want to talk about is really that step between the peat and before it turns to coal. There's a product called lignite or brown coal It's a little shallower in the soil profile. What we do as Monty's is we capture that brown coal. It's called lignite or lignardite. And then we take that and process that. And that's what we'll spend time talking about. You can actually crush that lignite, and it looks kind of like this, kind of a blackish brown material. Now, the tricky part about this is that by nature, humics are not soluble. There's different kinds of humics. There's fulvic, there's humic, and there's human. Of those three, fulvics are the only one that are naturally soluble, but humics, as a general rule, are not. And so the troubling part is you think about your plants. In order for it to move into inside of a plant, what does something have to be? Soluble, right? So in its natural state, humics don't work all that well. So there's a way that we have to use that we activate this brown coal. And we have a proprietary process that we have developed at Monty's that allows us to really engage a process that uses temperature, pressure, pH. We have agitation. We have some chemical agents as well that really take that natural state of a lignite particle that you saw in that previous slide and really open it up. And we make the sites, there's various sites on that humic particle. We activate those and open them up and make them available for attaching to nutrients, to water, to soil particles, and all that. So without really getting into the whole science behind it, but that is really critical because humics have become very popular in the last 4 to 5 years as we think about a lot of the high yielding growers in the country are utilizing humic technology. We know that it has a benefit in soil health and soil structure, but I will say that not all humics are created equal. So kind of do your homework when you're thinking about selecting a humic product. Obviously, we'd love to work with you at Monty's, but there's some other good products out there as well. However, some products out there simply take that brown coal, crush it up, and basically leaves you with a less soluble, inactive humic. And again, if we're going to invest that money into developing our soil health, we want to make sure that it's available to the soil and that it's ready. And so really what you want to look for is a soluble product that's clean, that's very bioactive, and Monty's humic technology through this process allows that. So one of the things that we like to do in a lot of our live meetings is just kind of show that difference. It's kind of difficult to do here on a web meeting, but you can take, this is one of our competitor products. You can put in a beaker of water. You can stir it up. You can let it sit. We've got one jar that's set on a cabinet for about 6.5 years, 7 years, and it's still, you can see those non-active humics just sitting in the bottom. Whereas you take a more active water-soluble product like our activated humics, you put that in the water and immediately it starts to break down, starts to be active in the soil. And again, solubility is important as we think about how it gets into the plant. It has to be soluble in water to move into a plant. So the end results you've seen, or if you've heard about humics, a lot of people get scared because they've heard of or people have tried humics. If you don't use a good activated humic, you get products that run out that look like this. You get that real gummy material in the bottom of jugs and sludge. And I know I've plugged a sprayer up before. It's no fun cleaning out 120-foot booms on a sprayer or unclogging a planter. And so, again, that activated humic technology is really critical in making sure that you have a high quality humic. So really, we think about, again, those three legs, the biological activity that's needed, the geological, and the chemical. And really, how do humics help each of these areas? So the biology, really what we're trying to do is provide a really good environment for the biology that you have in your soil. Biological new products are out there. That seems to be really popular right now as well. There's all kinds of either bugs in a jug or different types of biology that you can add to your soil. Monty's kind of our philosophy is let's make a really good environment for either the biology that's already in your soil or any that you may be adding, trying to make sure that it's a good place for your soil to live or your biology to live. The geological structure, again, is important as we think about how humics can impact compaction, really opening up those soil particles. We talked about those tight clays. Again, the addition of humics allows those soil particles to kind of open up to not hold on so tight, which again reduces compaction. We talked about soil exchange capacity as well, and the importance that it plays, how a humic can get in there and open up those positive soil, tie up the positive soil particles that allow nutrients to be more available to the plant, which is really important. So you think about, I kind of call humics kind of that Swiss Army knife of all the products you can use to put into your soil. Increased root growth. If the soil's healthy, it allows those plants to really put down roots. It also helps that structure's right, allows nutrient uptake to happen quicker and better. Again, if we're going to spend that money to put all these different products down, we got to make sure that they get into the plant. If a plant's healthy, then the plant quality is going to be better. The nutritional value inside of that plant is going to be improved. If a plant's healthy, just like we are, if we're healthy, we're able to defend off, the cold or the flu. Well, a plant is no different. And so we want to make sure that the natural defenses of that plant are good and that they're healthy. We know the benefit of improved soil structure on that first slide, what a healthy soil looks like, and that's our end goal. And then also differing soil pHs, trying to make sure that pH is right where we want it, where we can optimize it for the crop that we're growing. And humics play a huge part in that as well. So as you think about, again, there's tons of products you can place in your soil. Here's a list of just some of the products that we have. But you think about amending the soil. We have fertility that we can add in there. There's nutrient management. How can we move nutrients from the soil or from foliar applications into plants? We got micronutrients. And then also we'll talk a little bit about one of our specialty products and how we feed some of the soil biology as well. So there's a lot of different things and levers we can pull to have the proper response in our soil and in our plants, in our soil tests, and then also in our tissue sampling. So here's one example, and we talk about the humic family, and actually there's several kinds of humics. The two main ones that we deal with are humics and fulvics. And there's a lot of difference. We could get into the biology or the chemistry of how these are different. But the main things to understand is fulvics are really designed to stimulate, to chelate materials, and then also to drive them into a plant or into the root. So fulvics are really kind of that driving force that really helps us move nutrients. Humics are more there to protect the soil, to help accumulate nutrients as we apply them, to make them available for the plant roots, to store water, help hold on to water holding capacity, and build your soils. So that's really what those two types of technologies can do. And we have different products that allow you to depending on what you're trying to do and what the application timing is, it has different ratios of these humics and fulvics. So kind of our lead recommendation, and if you're trying to think about, I want to start into this some way, I've not dealt with these much, this is kind of the easy button, right? Here's the starter kit. Monty's liquid carbon or Monty's dry carbon are really kind of that foundational element of a lot of the programs that we run and we have success with our growers. Again, the benefits of Monty's liquid carbon or MLC, We stimulate that soil biology, we reduce compaction, moisture management. Also, the one that we haven't talked a lot about is by having a healthy soil and having a good biology in your soil, it also breaks down that plant residue. And what's trapped in that plant residue? Nutrients, right? The nutrients that we've applied in the past, we can break that down and make it quicker to be available to the plants. So MLC is kind of that first, or dry carbon is kind of that first step into healthier soils and improved yields. So you can apply MLC really at any time. I'll say some of our high yield growers use carbon at every application. Every time they go through the field, they're utilizing it. You don't have to do that to see the benefits. You can start out a little slower than that, but it can be applied with pre-plant applications. A lot of folks run 2x2. It can be put in furrow. It can be applied with liquid nitrogen, nutrient applications. And then also it really can be used to kind of condition that soil. So those are the when you can apply it throughout the season. So here's a real good example. I know we'll talk about salts later on in the program, but here's just one example of this is top dress of wheat, where one of our customers used 28% to top dress. And you can kind of get that burn, right? You go out there this time of year or a little later, you apply that 28%, you just kind of get that yellowing. Part of that yellowing, a lot of it is because of the salt that's in that 28%. One of the things that by adding MLC to it at a quart an acre, you can see the big difference between the kind of the salt buffering capacity that our MLC product can offer. So again, trying to keep that plant healthy, keep it growing. Yes, this will come out of it, but why put that plant through that stress if you don't have to? Also, one of the things that you'll notice after getting that soil healthy, using products like our MLC is doing root digs. I encourage you to go out there, run strips, test strips, dig up those roots, and you'll see just the root mass, how it improves as we get that soil balanced. So again, I don't want to make this sound like a big sales pitch. There are other products out there, but just understand that depending on what you're trying to accomplish, there's different products that are out there that can help you do that. So Monty's products, for example, dry carbon, that's really used as kind of a longer term product to help you rebuild soil. If you have a problem area or problem fields and you know that over the next 2 to 3 years, you want to really get a program that it improves that soil biology, dry carbon's your product. We have 2 other products called MLC, which we've talked about, Monty's liquid carbon and Fertilizer, which really stabilize that soil. Again, provide a good environment for soil health, for that soil biology. We have a product called Surge XD, which is a blend of humics and fulvics. Can be used in soil, can be used to help, the fulvics can be good also as to help with germination. And so Surge XD is kind of a product that has both humics and fulvics in it. We've recently introduced a pure fulvic. Remember that fulvic drives, really what drives nutrients into a plant. And so think about foliar applications of a nutrient, trying to get more boron into a plant, trying to get potassium into a plant. Fulvics are really good at using that as a driver. It also has some applications in furrow as well, as we think about nutrient uptake. And then we have a product called Humitil. After the season's over, let's break down those stalks. Let's break down the organic matter that's in the soil to get those nutrients returned back into the soil biology and back available for plants. So humics play a huge role in soil health and help building that. But one of the other things that we found that is really beneficial is adding a food source. So the humics, again, really create an environment that biology can thrive. Carbohydrates or sugars then feed that biology. And so putting these two products together in a program, it really is the Cadillac as far as trying to get your soil health and plant nutrition working as efficiently as possible. So one of the things that we recommend is using a product called AgriSweet. We also have a product called AgriN, and I'll talk about those two. But it's a sugar source. It's an energy source for the biology that's in those plants. And as you think about soil application, it really increases that microbial population. It really kind of energizes it and gives it something to feed off of. It also can work in foliar applications. You think about spraying some sugar over the top. Again, a lot of our high yielding growers put carbon and sugar on with every pass. Again, trying to stimulate the plant, trying to stimulate the biology that's in the soil, but also that foliar application allows that sugar to really amp up the photosynthesis in a plant. So our products, our AgriSweet, it's got two different sugar sources in it, fructose and glucose. Depending on what the plant's trying to do, those different sugar sources play different roles. The AgriN product is very similar, but it also adds a nitrogen component. So if you're trying to add a little bit more into that pass, you can use our AgriN product. Rates can vary, but 1 to 2 gallons per acre is what a lot of folks use. Again, in furrow, 2x2, foliar, very flexible application. So here's a bit more about the benefits of having that energy source, that food source for the biology. It really impacts more than just the soil. It helps make herbicide more effective. It also provides fuel for beneficial insects that are in the soil. We've talked about microbes already. Plant health. Plants create sugars through photosynthesis. By providing these natural sugars, it reduces lodging, which is always a good thing, standability, reduces plant stress, which again we know is important as we think about being able to weather those droughty periods throughout the summer. And then again, the main thing we've talked about all morning is the soil health. And we've talked about the benefits. So, MLC and a little bit of AgriSweet is a really good program to put you on the right path to soil health. So one other thing that we get a lot of questions about is different sugar sources. And so there's a lot of sugar products out there on the market. I think things to watch for. Think about the viscosity of sugar products. Sometimes that's how it flows through your system. It can be challenging, especially in those cool spring days when we're out there running our spray equipment. We want to understand that viscosity and how it can blend with other products. Also think about the forms of sugar. That's important as well. The different processes and use different sugar sources. So for example, glucose and fructose in ours, some just have a single source of sugar. So you get a little bit more, I think, and a wider spectrum of influence when you use multiple sugar sources. And then think about things like concentration and then dilution. Is it ready to use? We also add some proprietary surfactant that kind of helps that AgriSweet be more active in the soil as well. So again, not all sugars are equal. Yeah, some growers, you can go out and get table sugar and you can utilize that. But, I think sometimes if we're going to the process to improve our soil, investing in a good sugar source that's active in the soil quickly, that mixes well is really important. So that's kind of the role. Again, humics provide a really good environment for the biology. The AgriSweet product provides the energy for that biology to really thrive and really balances the soil. So again, that's kind of what I had prepared today to talk about. Getting that soil balanced, utilizing different technologies to make sure that our soils are biologically ready to do what we need them to do with the soil biology and the microbes. They're chemically ready. Our CECs are balanced. Our pHs are there. We have the right nutrients there. And then our soil structure is in the right place. Allows for the right compaction or lack of compaction, and the soil structure is ready for root development. So, we have programs that work well in really all crops, row crops, hay and forage, pastures, truck crops. We have programs that are developed for all those, and we'd be happy to sit down with you, look through your soil tests and your tissue samples, and develop a program that helps you kind of balance that soil health. So I'll open it up. Are there any questions for me? All right. Well, if you have any, feel free to put those in the chat or shoot Paul a message, and we'd be happy to help answer any of your questions. Paul and Joe, we'll turn it back over to you.
All right. Okay. Phil, we thank you for that. I would like to add one thing on the sugars. The AgriSweet, as Phil said, is a combination of glucose and fructose. And that doesn't sound like much to anybody, but a lot of insects cannot digest fructose. So vegetable growers, guys that growing soybeans, if you're coming over top and you have a mite issue, if you're putting an insecticide out there to kill the mites, add the AgriSweet with it. It will help to get that into the plant better, and the mites cannot digest the fructose. So you're getting basically two modes of action on covering your insect problem. So that's just something else to think about. Phil, we thank you for that. I'm going to move into some fertilizer stuff here, and we'll go through that. And then Joe's going to talk about salts. So Joe, if you'll stick my presentation up, please.
Okay, bear with me a second. Called technical difficulty. You run into this from time to time, especially in when you have China hacking in your systems and stuff like that. So sure. Here we go. Let's try this. All right.
There we go. There we go. All right. So I'm going to try to work through this a little bit. I want to talk about, are your fertilizers really working for you? I'm going to discuss polys versus orthos. Going to talk about some ortho poly blends, and then talk about some 100% ortho products, and then kind of go over some other products that Monty's has to offer as well. So what is a poly fertilizer? Poly fertilizers are called green acids. It's the first process that phosphates go through when making a dry into a liquid. So I'm no chemist, but I'll kind of work through this the best that I can. You take the dry phosphorus, you melt it down, you get a product that is green in color, similar to, it would be like your 1034O or your 1137O. It's in a poly form, which is still a source that the plant cannot use. It has to convert to an ortho. In order to convert, it takes heat, it takes moisture, time to convert that poly into an ortho. And that can take up to between 45 and 75 days for that product to convert from a poly to an ortho where the plant can use it. So if you're using a 1034-0 or an 1137-0 as your starter, you could be, 45 to 75 days later before the plant ever gets to use that fertilizer that you've put in the ground. So we're going to talk about that a little more as we go forward. But anyway, poly is green in color. It still contains heavy metals such as aluminum, mercury, arsenic, and other metals. Well, aluminum will bind phosphorus up. So you've got a product that has phosphorus in it. You're trying to get phosphorus into the plant, but the aluminum is holding it back. It's not letting it get there. So we'll keep going here. I want to let you know that polyfertilizers also contain salts. You do not necessarily want to put them in furrow with the seeds because you can cause root damage. So let's see here, next slide. So step 2, you take that green acid, you run it through another process, and you get what they call a yellow product. It is an ortho product. So you've converted it from a poly to an ortho, normally yellow in color, still contains heavy metals, but now it is in the ortho form. So it's available to the plant. But again, you've still got aluminum in there that's binding that phosphorus up. You can use it in the furrow with seed. And this is the product that many companies use to make their starters from. And still, as I say, it has those heavy metals in it. So we kind of go another process. The third step, you take that product, you run it through another process, you get to 100% ortho product. It's removed all the heavy metals. It's removed the salt, or most of the salt. It makes it a clear product. It almost looks like water. Monty's goes to this step. We use this in our premium blend. We use it in our Hay Now, our Root and Bloom, our all-purpose, and some of our other products as well. This product is readily available to the plant as soon as it's ready to accept it. So as soon as that plant germinates, gets a root system on it, it can take this fertilizer in and go to work. So that makes a lot of difference in what we're trying to accomplish. Next slide there. Monty's Premium Blend 624-6, 1 sulfur, 0.05 zinc. It is 100% food grade ortho. Use it in furrow at 2.5 to 5 gallon per acre to provide your nutrition. This product is 100% ortho product, so it cannot be mixed with liquid nitrogen. They will not mix together. We've taken the heavy metals out so they're not in there to tie the nutrients up in the ground. It's a low salt formula, and we also add our Monty's liquid carbon to the premium blend, which helps to stimulate the bacteria there in that root zone and get that product into the root of that plant. And as you can see in the picture, that's what we're shooting for. We want that real nice root growth early on so that plant can feed itself throughout the year. All right. Blends. A lot of companies sell you a blend, an ortho with a poly to extend the fertilizer longer into the growing season. These are normally an 80% ortho and a 20% poly. Some may be 60-40. These products, because they use the yellow acid, these are normally still have the heavy metals in them. They do contain more salts than a pure ortho does. So you have to kind of know what you're getting. Some guys are using these in furrow. I still do not like to use them in furrow because they still have some salt load there. Most of this would be in your 2x2 or a 2x3 program. And they can be mixed with liquid nitrogen because they have some poly in them, and poly will mix with liquid nitrogen. Examples of this are 924-3 and a 624-6 blended product. A lot of fertilizers contain high salt levels, and Joe's going to go over that when we get here. When soil testing, check the salt levels in your soil. You can request, not all labs will do it automatically. Some of them do, but you can request a test to tell you how much salt is in your soil. And then design yourself a program to utilize lower salt products so that you can bring that salt level down. Just one example that I'm going to say, and then Joe will talk about this more later, but the muriate of potash, 0060 or 0062, very high in salt. You could switch to a sulfate of potash, which is an 0050, and it's a low salt product. There is a huge price difference. 0050 normally runs 40 to 50% higher than 0060. I've got growers that have switched from 0060 to the 0050, the sulfate. They've cut their rate in half or cut it down to where they're keeping their price per acre close to the same. Great results as far as root development goes. Great results in hay for longevity of the stand. And honestly, in their soil test results that they're getting back, they really have not changed their potash levels in the soil. So it's available to the plant a little better. So that's just one example. And Joe's going to go over some things when he does his presentation. Next slide, Joe.
It's going to be me.
Oh, okay. Before I go on to that, I kind of want to go over a couple of fertilizers that we carry. We've got, everybody has seen our catalog, or most of you guys have seen our catalog, and we list a few things in there, but we don't have everything listed. Our premium blend is in there, which is a 100% ortho product. We also can get a 6-19-14, a 6-3-18, a 3-18-18. So we can get other 100% ortho products. If you have a certain product that you want, please get in touch with us. We can probably get that made up and get it to you. We also have some blends for your 2x2 or 2x3 applications. We have the 924-3 that can be mixed with nitrogen. We have a 624-6 that's a blend. So a lot of different things. We also carry our potassium product, our K28, which is in the book, but we also carry a potassium acetate and a potassium formate. So we can get both of those products as well. So just because it's not in the book doesn't mean that we can't get it. So, contact myself or one of the reps or whatever, if there's something that you want to do. Get a soil test. Let's sit down and look things over and try to come up with a program for you for your crop. So with that, I'm going to turn it over to Joe to talk about salt.
Thank you, Paul. So we're going to talk about what's happening in your soils with all the salts that you're putting on it. My background is I was in a dairy farm for 13 years. Once I got rid of that, I've been on vacation ever since. But it's been a wonderful trip with Monty's and many things that we have discovered and are able to help farmers with solutions to a lot of their issues that's out there in the soil. So I wanted to touch on things that I have learned through actually kind of diving into doing some research and stuff on when I was presenting this about salts. So I want you to know that your soil is alive, and what we do to it affects its health. I mean, Phil alluded to that under the soil health part. Um, Everything on Earth, plants, animals, humans, they all have an energy source, and we all have energy. So two rules in nature exist. 80% of a plant comes from the air. Everything it gets comes from the air. 20% comes from the soil. So plants grow on the energy released from the interaction of these nutrients. And then, as Paul even touched on, phosphorus should enter the plant in the phosphate form. You can throw all the fertilizer out there you want, but if you cannot get your soil health or your soil biology to convert it into a phosphate form, you're not going to get it into the plant. And then calcium helps determine the volume of crop and is the major element against which other nutrients react. It is your most major nutrient in the soil to react with everything. Carbon's a big key component, and the key to carbon fixation is aerobic bacteria. So when we look at that, and we're talking about photosynthesis, we have to have all plants that you grow has to go through this photosynthesis. And so understanding that photosynthesis and respiration are helping in growing your crop and getting you to the highest yield you can, it all plays along with the importance of phosphate, the phosphate's relationship to sugar. And I'm talking sugar in the plant because that's what it's developing from the photosynthesis. And then the relationship of true quality or mineral content to the phosphate and the sugar. We are always in search of answers, and I hope you are too. We love going out working with farmers, especially when they have issues that is developed in their fields or in their crops, and see if we cannot help provide solutions or get to the bottom and get the answers that they're looking for, and then get back to them on that. So we know that these 9 particular statements that are here are very, very important to growing our crops every single year. Phil touched on this about the antagonism when you have too much of one thing, one different nutrient in the soil. And this is going to play right into our salt balance that's in the soil, along with your pH factor. How crazy is it that a lot of soils that we look at with farmers, and usually the ones that are having the problems, are either in the 6s, low 6, or even in 5s, and look at your fertilizer efficiency. When the lower the pH goes, then you're going to have less and less efficiency of the fertilizer you've thrown out there on the soil. This is one of the reasons that our liquid programs perform so well, is because it's immediately available to the plant. It's right there and it's good to go. I wanted to show you this just real quickly. I run across this the other day. I had a farmer send this to me. In this case, you've got a very low pH. You got low CEC. So as you can tell, this is kind of sandy soil. But I've never seen potash as high of a base saturation in that 25.7. And look at your calcium. So remember, calcium was the major nutrient that puts all the other nutrients into the plant, and this is only at a 29% base saturation. That is extremely low. So even, and I'll use this as an example, if you went out through dry fertilizer on this soil, you remember the chart we just saw? I mean, you're almost throwing your money away because you don't have the calcium there. You don't have other factors there to react with it, especially more than likely, you don't have the biology there to work for you. And you're going to get terrible efficiency out of any dry product. So liquids would become your best friend to use in a situation like that, because you're putting it directly next to the seed, next to the row, and getting better absorption. I just want to show you this salt index so that you know what you're dealing with each and every year, whether it's anhydrous ammonia or urea or whatever your UAN even that you're using. All fertilizers have tremendous salt index to them. So you can imagine now, when you see this kind of index, of all the years that you've been going out and putting on dry fertilizers, you have, whether you may know it or not, but you have a buildup in your soil of salt level. Let's just say a particular range of salt that's in your soil that is inhibiting your soil biology. So one of the, and I hate to even say this because Paul and I and Phil and Dennis all worked with Southern States for years. Many of you guys may even buy from them. And we sold muriate of potash is the leading potash. But I want to show you what it's doing to your soil. It's really bad. So when we talk about muriate of potash, is our leading one that we use quite a bit, and the bad component in it is chlorine. So it contains anywhere from 40 to 47% chlorine. Chlorine is in nature, once you hit it into the soil and it begins to react, then the chlorine will form this muriatic acid, also known as hydrochloric acid, which destroys any bacteria it comes in contact with. And it also helps to acidify the soil, causing such minerals as calcium and iron to become less available in the soil solution should they contact the muriatic acid. So again, this same chlorine that does not become muriatic acid, combines then with calcium and magnesium, and especially sodium, to form chloride salts that are also detrimental in the soil. And they will also, remember, salts is just like you. If you ate way too much salt, you're going to dehydrate yourself. Well, this is exactly what the chlorine and in that muriate of potash is doing. It dehydrates the soil, even causing adverse pH changes and even salting out in the soil. So when potassium chloride also contacts nitrate nitrogen, then half of the chlorine forms hydrochlorous acid, the main chemical used as a swimming pool disinfectant. So this compound is very hostile to the environment, the microbes and the bacteria, and it also inhibits their growth. The other half of the chloride forms chlorine gas, which shifts up into the air, and chlorine gas is also toxic to biological life. So the use of potassium chloride also leads to compacted soils due to the destruction of organics it causes, requiring more power for you to till with, more chemicals to be applied, more pest control. Furthermore, the use of potassium chloride for fertilization leads to eventual desertification. In other words, dries out the soil. And then most important of all, it leads to the production of poor quality crops, mineral deficient. It's imperative to purchase only products that do not contain chloride. The bottom line is that potassium chloride causes the demise of soil fertility, leading to the need for more and more fertilizer, greater amounts of pesticides, and larger and more powerful equipment to get through your soil. So I want to show you this example. This is some of the research I uncovered. Let's just calculate what we're doing out there every year. So because it has the 47% chlorine in it, in the 1 acre slice, many of you have heard like 6 inches deep is like 2 million pounds of material. So if a farmer applies 100 pounds of potassium chloride, he has applied 47 pounds of chlorine. To calculate the chlorine concentration, assuming the fertilizer is dispersed evenly throughout the 6 inches of soil, then you would take the 47 pounds of chlorine divided by 2 million pounds of soil, and you'd end up with 24 parts per million of chlorine, or about 11 times more that's needed to kill the microorganisms in the soil. Now, the truth is most farmers apply several times that amount, sometimes as much as 1,000 pounds, depending on what crop that they're growing. And potassium chloride each and every year, they're doing this. An example would be 250 pounds or 150 units of calcium chloride would lead to a 60 parts per million salt concentration in the soil. And then even sometimes on various crops, we've done as much as 300 pounds, which has led to as much as 84.6 pounds of chlorine that we're putting out there in the soil. So I guess my whole point here is if you're not seeing the performance out of your soils and into your crops, because these components are inhibiting not only the biologicals, not only the bacteria and the fungi in the soil, but it's interacting with other nutrients in a negative way, not allowing them to come up into the plant. And therefore, you're struggling to get to these higher yields. So this high salt buildup that's happening, it's happening in both acidic soils as well as alkaline soils. So when your pH is really high or your pH is really low, it's still there, and it's causing yourself some problems. So the salt buildup has two major causes: the destruction of organics by toxic fertilizers and the use of high salt fertilizers, both of which destroy these organics. The salt dehydrates the soil, causes excess current flow. So you see in the pictures, even over here, when you have high salt buildups in your soil, the soil dries out. It changes the structure, it changes the texture, and then you end up with soils that are not as productive as you would like for them to be. So in addition, you'll need more and more water is needed for you to hit the yields goals that you have in mind because of these salts that are in your soil. So when we think about it, the bottom line here is all these practices that are directly and indirectly destroy the organics, the biologically active carbons that determine the soil's vitality and fertility, is leading you down a path where you're getting either less and less yield, or you cannot achieve the kind of yields that you're looking for. And then organic matter can take two pathways: anaerobic, like we're super wet underwater, resulting in organic salts, formaldehydes, soil demise, or aerobic, which is what we want, resulting in humus, soil maintenance, and rejuvenation. Once either cycle is in motion, it takes a tremendous countermeasure to change. So we run into this all the time, especially with farmers, that when we come out and we look at their soil, we diagnose it with either a soil sample or tissue samples or things like that when we're trying to provide solutions. Then we see that the remediation of that soil is needed. Now you go back to what Phil introduced us to with the humics and the sugars. That is your best path to remediating salts issues out of the soil. But at the same time, you've got a product that will remediate, but at the same time, you have to quit putting on these kinds of heavy salt materials and become more efficient in what you use. And that's the nature of our humics and the sugars combination. It will increase the efficiency of what you are doing. In many cases, I know many of you probably know or have heard of Dr. Haniger over at NC State. He has been testing our product and working with us for well over 10 years. And he has made the statement many times that by using the catalyst of humics and sugars together, farmers can reduce their application of dry fertilizer by as much as 20% and still have better efficiency and better uptake by doing that. And so again, we're looking at this response of salts and what it's doing in the soil. All this biological life that's there has energy in it when you are using or have a buildup of salts in the soil, because every product you put, whether it's dry nitrogen, liquid nitrogen, potash, phosphates, even other micronutrients, start in a salt form, and then they are either treated or they're changed or they're not. And in most cases, the dry is a salt mineral that the soil has to break down. Because remember this, if you can throw all the fertilizer you want on that soil, but if you don't have microbial activity in that soil to break it down and turn it into a usable form the plant can use, it's just going to lay there. So this is one of the factors that soil biology is so important. When we're talking about soil health at the beginning, that is your number one goal, is how do I increase or how do I deal with improving my soil biology? So salts, this is in conjunction with the salts that's being put out there in the soil. Remember that we're throwing the soil in a disbalance. It's not balanced anymore when you have high salt levels. So it's also plays right into insects and weeds and stuff, which we're going to throw in here as well. But remember that most people think that a pest is a pest, just insects are out there. But actually, insects have a very distinct and important task. They devour. Now, here's some really neat stuff. Each species of insect has in its genetic structure a specific food for it to devour, and that food is determined by frequency. Everything emits infrared radiation, and each thing has its own specific range of vibration. The vibrational frequency of all the component parts of a thing makes up its composite vibrational frequency. This is what the insect receives and processes. So when you have a crop or a plant out there that is sick, you see it sick, mainly, and when we talk about sick, it could be nutrient deficiency. Well, that plant, when it starves for one nutrient or another, will put off a different frequency. And lo and behold, here comes an insect to devour it. So if there happens to be a mineral deficiency, it'll vibrate it at a different frequency. Once the quality of the crop surpasses a given level, there will not be an insect problem. And I'm talking about a sugar content, like we talk about Brix level. You get Brix level above 10 to 12, and your insect problem goes away for the most part, because they cannot digest a healthy plant that has a sugar content like that. So even diseases trigger in the plant different signals, different frequencies. And if you correct that deficiency, usually the disease goes away or the insects won't feed. So how do salts relate to weeds? Well, like insects and diseases, weeds have a distinct purpose to replenish the soil. Weeds are the best soil tests you can use. Each weed species is genetically keyed to replace a specific deficiency. Now, here's an example. All the weeds are divided into broadleaf grasses and succulents. So generally speaking, broadleaf weeds are present to correct the imbalance ratio between phosphate and potash. We usually look at these ratios as 2 parts phosphate, 1 part potash. For row crops, vegetables are higher at a 4-to-1 ratio along with grasses. So here's a little carrot to go by. Typically, you'll find the ratios not only reversed, but as bad as 10 parts potash to 1 part phosphate. So broadleaf weeds act to detoxify chemicals in the soil through metabolic processes. Grasses, such as foxtail, quackgrass, are generally present to correct a calcium deficiency. And then succulents are usually present to replenish carbonate ions in the soil, as well as increase in water holding capacity. So weeds have a role, just like insects have a role. Remember, Mother Nature is way smarter than us. So here's a diagram just for your benefit that you can look at whether it's new growth or old growth, and those are the signs that will show up in those areas. So the older leaves will show up these kinds of signs. Iron or calcium will show up in the newest leaves if you see a deficiency that's out there. Remember, this is a growing sequence in every plant that's on the planet. It literally starts with boron. Most of the time, everyone probably has enough silica in your soil, but it combines with that and calcium and then begins to carry it through these other nutrients and transfers it into the plant. So when you talk about a plant taking up phosphate or potash or something in a form that it can use, it goes through these kinds of processes of the nutrients that's in the soil. So you can imagine if this is a sequence and you have one of these or even several of these way out of balance, you're not going to get the efficiency to grow that plant that you would like to see. And we know that when we were talking about earlier of how the root and the rhizosphere takes in, there's a symbiotic relationship between the root hairs and the root and the soil biology. They communicate all the time. So when a plant is growing, remember the photosynthesis photo, it's producing carbohydrates and sugars. It exudes those through the root system. We see this in a close-up where it exudes these sugars out to feed the biology. And in turn, they have all kinds of signals in that exudate that says, I need potash, I need zinc, I need something else. And the biology goes and gets it, so it keeps getting the food coming from the plant. So that this is that symbiotic relationship. Then we see it in the root mass. So again, there's even biology in the soil that will help produce vitamins. They have hormones, they have growth regulators. They've got all kinds of things in the soil when it's a good, healthy soil. You remember the slide that Phil showed you with the green side where everything is the way it's supposed to be, then things go really well and you get higher yields. I'll throw this in because anhydrous is a huge salt factor too, and many farmers are using anhydrous. So the practice of this, and by all means, use extreme caution. This is one of the more popular products, and anhydrous means the water is removed, leaving only ammonia. You can read little articles on the internet how that they used anhydrous ammonia to build airfields in a lot of times in wartime because it dries out the soil and packs it tight. So again, we're dealing with compaction, and this is where the soil biology, the humics, the sugars help relieve lots of those factors, these problems that you have in your field. So I think it was Phil that showed you if you want to begin a program of remediation, whether no matter what you're using here in anhydrous, liquid nitrogen, potash, dry fertilizer, it all starts with humics and sugars because you're doing two things together that work synergistically together to remediate your soils and get them going again. And this is where soil testing and tissue testing will also provide great information for you. So that's what I have. If you have any questions, by all means, speak up. If not, we'll be ready to go to Dennis Paul.
Thanks, Joe. Appreciate that. So guys, remember, there's different sources of fertilizers as we talked about before. if you're using the 0060 or the 0062 or the anhydrous, or you're using biosolids, you know, things like that that are high in salts and high in heavy metals, just make sure that you're using carbon and sugar to help buffer that, to help the soil recover some from what we're doing to it. So, uh, big things there. And Joe, we thank you for that. I'm going to turn it over to Dennis Stevens. Dennis is going to talk about water. I was at a grower meeting yesterday, and a fellow got up and was talking about Roundup and some fungicides and other things. And he discussed water issues. So, water is something that we have not taken a look at. We often complain that our chemistry isn't working, and we blame it on weather and other things, but water could be that limiting factor. So, Dennis, if you would take over and give us your presentation, please.
All right. Well, first of all, I'm gonna apologize for you may have issues with the way I sound, but I will trudge through this. And if you get to a point that you need me to take a drink or something like that that you can't understand, but ultimately, the best way, and this is a prime example, the best thing for me to do right now is actually drink more water with what I'm facing, because water is a limiting factor with a lot of things that you're doing. And so when you talk to the doctor and you're saying, well, what medicine can I take? One of the things that they tell you is, well, make sure you're drinking a lot more water. But we got to make sure that the water source is not going to become a limiting factor. One of the things that I will have to share is that whether this is the right thing or not, can I advance it? Okay.
Just tell me to advance it, please.
So just knowing that when we make nitrogen, phosphorus, potash, we make these blends, the thought of what it's going to go into or what the water source is isn't the prime thing that we think about, because the raw materials are sourced typically based on material value and availability. So just know going into it that this is the way that the industry is set up. We then have to realize that this is what we're going to have to work with and how it's going to interact. And this may be that you may have water that's hard, and we'll actually go through and talk about, because Paul shared with me that in your area, you actually have hard water. And so we have solutions, and these are something that you need to really focus in on how to do that. And the reason that I talk about that is that when we say pH, what does that mean? Well, your lower pH typically signals that you have more hydrogen ions. If the pH goes above 7, then you have more free hydroxyl ions. And so if you understand that when a plant is actually releasing from its root system, it actually releases free hydrogen. It doesn't release hydroxyl ions. And why is that important? That actually is nature's way of releasing things and making things available. And so the understanding then how plants absorb, we have an active transport. And I tie this in because where we talk about having sugars and other things, if we're dealing with something that has a much stronger molecular charge, you're going to have something, you're going to need something in order to drive that into the plant, because an active transport is one description, and then the other one is a passive transport. And so knowing that your active transport, because we're dealing sometimes with a mixture that may have, and believe me, we're stacking more and more things together because we're trying to go less and less across the field. So the more that we increase the molecular structure, we need things in order to increase, one, so that they can go into the plant. But to go back to even the point of Joe, when he talked about the buildup of salt, that salt actually has a charge. So from a physics standpoint, what we know of is that that charge actually affects and actually reacts with the hydrogen, the plus hydrogen plus. And so the more that you go back to canceling things out, you limit the uptake. So we think through these things when we get the source that we're going to be creating. And from that, what we're trying to do is say, how can we drive things into the plant? The simplest way to do that is through the passive transport, and that requires less energy. But because we know that what has been developed in what we have done over the years with our practices, we have to come up with things, and that's why your sugar, your carbons, and some things that we'll be even looking at even more, your amino acids, your peptides, on how important those play a factor in getting things into the plant. Again, the quicker and more efficient with less energy into the plant gives you a much better sense of being able, or a better success in order to be driving your yields without losing yield. Okay, Joe. So I bring this because when I was thinking through how I was going to go about what we're doing with water, we developed a product, and we really don't do a whole lot of education about it, but we created a product called Calisco. And we know that people have used AMS for years to go into that. But we realized that because of how AMS works, doesn't necessarily bind things. And so we created Calisco because where we were saying that your source of hard water, we can add this. What it does is it actually makes your ability to utilize your pesticides, your Roundup, because if you do have hard water, and I'll be at the next slide, I'll be able to show you what we were able to do in order to release that. But understand these bonds that take place with the Calisco make it so that we're not canceling things out. We're actually trying to utilize what you have available through your water. Okay, Joe. So here's the chart where we ran some tests. So if you look at it, when we do the treatment with Calisco as compared to AMS, we took that from 250 parts per million down to 25, whereas with your AMS, went with 120. So the significance of that is, yes, we treated the hardness, but we also still kept the utilization of the iron and the other elements that are needed into the plant. We didn't cancel those out. We're still making those available, whereas your AMS would cancel out the ability for absorbing the iron. This was I know this is not nutrient related, but this was a test that we actually did with Colesko and understanding how it could be utilized. And so you can see when you use it with a Roundup, how it was able to go in and apply that to the crop or to the grass area, and you can see how it was able to really be effective. Because again, not just with the herbicides, but also think through when you're utilizing these products, because Colesko, even though it's a different technology, it's still in a nano form of technology. So when we deal with nanos, we deal with nano and humics and with other things, and those are just measurements. And so both of those function so that we are able to utilize nutrient uptake, and then also be able to the less energy that your plant has to utilize in order to get the plant to uptake, you're actually not taking away yield. That is the main thing that we want to utilize. So this is about all that I have presented. I'm not necessarily a qualified teacher, so I'm not like a Joe, but if you have questions, I'll be glad to answer any questions that you might have. Because the other thing that I do a lot of times when we're creating formulas, I do try to think of how it's going to react when we have different water sources. Because ultimately, if what we do is supply something to you that is not going to be able to be functional for you, we've got to make modifications. And that happens when we get feedback and we have discussions with you as growers.
Dennis, you made the point here on this last slide too, and I'll just reemphasize. If you farmers are having any kind of problems like with adding your spray material to your tank, going out and spraying and not getting good kills on whatever weed you're spraying, I highly recommend you test your water for hardness, because the hardness of that water will not, the harder the water, it won't go into the plant or into the leaves, which is what you're kind of seeing here in this diagram. And this is where the Colesko product would be beneficial to you to increase the efficiency of the chemicals that you're applying to make them perform better, and possibly even a better kill or better, quicker kill even. So it's taking the competition away from your crop. But just take a look at that, because water definitely plays a huge role. We don't think about it a lot of times. City water will have a lot of hardness. Sometimes well water has a lot of hardness. This is where you really, just like you take a soil sample or a tissue sample, I highly suggest you test your water.
Joe, I'd like to add to that as well. Here in Maryland, Delaware, our average water pH is around 7, which you'd think that a neutral type pH would work well with everything. But from what I've seen and read, products like Roundup operate best in a 5.5 to 5.7 range.
Right.
So yes, you need to change this 7 pH down to that 5.5 to 5.7 to make sure that Roundup is working to 100% of its ability. So that's something that you need to take a look at also when you're spraying these herbicides and even fungicides, trying to get stuff into the plant. We need to know where we need to have that optimal range at. All right, if anybody doesn't have any questions, I'm kind of going to go into a little bit of a program here. I'm not going to get into it real deep. We have Monty's has a real nice crop sheet for each crop, soybeans, wheat, corn, hay, and pasture. I will attach those to the recording when I send that out so that you'll have those. And it's kind of a step-by-step timing sheet that tells you what product to use at what growth stage and things like that. So I'm kind of going to go through this here a little bit. But no matter what crop you're growing, start with the carbon and the AgriSuite as your foundation. You know, we've heard salt issues, we've heard issues about soil health and how nutrients are tied up in the soil, and we need to release all of that. We have residue issues. So, you know, carbon and sugar boost those microbes in that soil, get them working to the best of their ability. And let's start there. Carbon works on soil structure, texture, releases tied up nutrients. I call it a 1-2 punch. You know, carbon stimulates the bacteria and the fungi, gets them moving. The AgriSuite is a carbohydrate source that feeds them and just makes them continue to multiply. And of course, the more that you have in the soil, the better that your soil is going to work. So kind of a 1-2 punch on that. So we can use them on corn. If your planter has the ability to have an in-furrow starter, a lot of guys use 2 quarts of Monty's liquid carbon and 2 quarts of the AgriSuite right in furrow with the seed. Kind of creates a little hot zone there. You know, when the bacteria get working, they create some heat. So you get a little hot zone, and you get quicker emergence, quicker germination, quicker emergence. It also helps to release those nutrients that are tied up there for better root growth. If you're needing an in-furrow fertilizer or wanting to use an in-furrow fertilizer, we recommend the premium blend, which is 100% food grade ortho, as I went over earlier, at the rate of 2 to 3 gallon per acre. So next slide there, Joe. Here's a picture of the chart that I'm talking about that I will include. Some other things that you can do is foliar apply some 924-3 or Noxin, which is our micronutrient blend with some potash and sugar in it. You know, premium blend, you can Y drop products. It just depends on what your program is. And we would like to be able to work with each one of you to design your program to help you see where you can put certain products that may help. We have a product called Midnight, which is a product that helps the plant capture more daylight, more sunshine. So, you know, talk with us, talk with your rep. We'll work a program that will work for you. And as I say, I'm going to attach these sheets to the video. Soybeans, same as corn. Monty's liquid carbon and AgriSuite in furrow if possible. A lot of guys planting 15-inch rows do not have the capability of putting fertilizer on. Spray it down with your burn down, spray it down with your residual program. You know, get it on the ground. Let's get them bacteria going. And you can also add some premium blend in there. If it's in furrow, I like to not go over a gallon to the acre. When I'm broadcast spraying over top, even after the beans are up, I'll go 2 gallon on the premium blend. Other products there, again, the midnight product. We can add sulfur 15. We can add K28. I'm kind of going to touch on the K28 just a minute. Soybeans typically use 80% of their potash needs between blossom and pod fill. At that point, the plant is done growing. It's pretty well as tall as it's going to get, and it's not pulling nutrients up out of the soil as it did through the growth stage. So we have to apply some nutrients. And if it's using most of its potash at that time, that's when I want to add some potash. Joe, if you'll click the next slide there, please. You know, again, put the carbon, the AgriSuite, the premium blend down early, and then come back at growth stage somewhere around V3. Add microhance or Noxin, sulfur 15 if you need some sulfur, K28, that's a good time to add it. Como B, which is your cobalt, moly, and boron. And then when you get to the reproductive pod set stage, that's where the K28, the AgriSuite, and the Noxin will really make that plant hold some more pods on and fill those pods out. So as again, I'll attach this sheet to it. Tissue sampling. Let's just talk about tissue sampling here real quick. You know, we normally all take soil tests at the beginning of the year to see what's in the dirt. But when you go to the doctor, the first thing he wants to do is take a blood sample to see what you've got in your system. So we need to do the same thing with the corn and the soybeans and the alfalfa and the vegetables and that sort of thing. So pulling a tissue sample and looking at where your levels are and looking at where they ought to be. You know, there's times that we know that when corn reaches a certain point, we want a fair amount of boron in the plant, or we want a fair amount of nitrogen in the plant. So, you know, pulling that tissue sample, take a look at what's there, and then apply products that will get you to those levels. So we do have products designed for those needs. We carry all kinds of micronutrients, the zinc, the boron, the manganese, the iron, other things as standalone products, but we also have them in our blends, which are microhance and Noxin. So great tool for determining the plant's needs. So you know, take a look at pulling some tissue samples as we go through the spring. Joe's got on here, you know, you look at, you want to tell the lab what growth stage it's in. So there's a corn plant and you're looking at the collared leaves. So when you go out and pull this tissue sample, 5 is your last collared leaf. That is the leaf that you want to pull for that soil test. You know, as I said, talk with us, talk with your dealers, whatever, but let's try to get some tissue samples to see where you're at and go from there. All right, Joan, next one. Wheat, you know, we planted in the fall of the year. We kind of forget about it, but in the fall, use the liquid carbon and the AgriSuite, or use our Humitil product. Humitil will help break down the residue. So if you're planting wheat behind corn, break that residue down, let those nutrients get into the soil so that the wheat can take those up in the fall of the year to help it make it through winter. When spring comes and you go to top dress that wheat, you're going to put your nitrogen on it. And Phil showed the slide. You know, if nothing else, you want to put the MLC in there, 1 quart for every 20 gallons of nitrogen, to help buffer the salts and cause less burn. Anytime we burn that leaf anytime we set that plant back, we've hurt that plant. So we want to keep it as healthy as possible. You reduce the burn, and you keep that plant going like it should. Also, when the wheat gets, you can apply your microhance, your Noxin to get your micronutrients in there. But when that wheat heads out, and that's a point where we're all hitting now with a fungicide because of head scab and some other things. But that's a good time to apply some K28. It's a good time to apply some AgriSweet. Get some sugar, some carbohydrates into that plant to help it continue to fill that head out, give it that boost of energy that it needs. So those are some things that we can do per crop. Thank you for attending. I'll send the crop sheets out as an attachment when we send the recording. We've kind of got into a few things as far as digging in a little deeper. I'm going to put a little plug in here for our MAC school. Monty's has been working with the MAC group for several years now with Kevin Cobb. Kevin is one of the country's best corn growers. I don't know how many times he's an NCGA winner, but it's quite a few. And if anybody's interested in learning a lot more, you may want to check into to joining that school with him. He gets into it very deep. I know that farmers all the time are putting their soil tests or tissue samples up, and he's helping to make the recommendations and go through the crops and telling you what products you should be using. So that's another avenue for you if you're looking to go a little further. Again, take 10, 20 acres, take a field. If you haven't been using Monty's products, and pick some products. I would say start with the carbon and the AgriSweet. Put it on that piece of ground, and let's try to improve what you're doing. Talk to your rep, and your dealer, and let's get Monty's out there. At Monty's, we would love to see Monty's products on every acre. Whether it be carbon or sugar or our foliar products or a premium blend. But you have to start somewhere. And, I had a guy tell me one time, he said, I took over from my dad when I was 30, and I turned it over to my children when I was 60. So I grew 30 crops. So you get the opportunity to grow about 30 crops, and you want to make each one of them count. So, there's no go back and start in the middle. So, that's something you may want to consider. And we've got to figure out what works and how to improve our ROI, and our products will help you do that. So I appreciate your time. I appreciate the guys helping me with this, Joe and Dennis and Phil. And if there's any questions, my number is there, email address is there. You can contact me, contact those guys, get on get with our other reps or dealers, go to our website, www.montysplantfood.com. Some really good information there as well. Look forward to seeing those of you that will be coming to the National Farm Machinery Show and also to the Commodity Classic. And have a great growing season. Appreciate it very much. Thank you.
Thank you, guys.
Thank you.